This is section 2.7. This is part 6. Okay, so this is something kind of new. We have negative 6 is less than or equal to x plus 7 is less than or equal to 10. This is just saying that we're looking for something that is between negative 6 and positive 10. Okay? This is essentially a three-sided problem. It looks a lot worse than it is. We treat it pretty much the same way. What we want to have happen, though, is we want our variable alone in the middle. Okay? And then whatever you do to one side, you do to the other too. So you treat it like three problems. There is a way to split this type of problem into two and work them separately, but it's really kind of tricky to get them back together into one answer. This is generally easier. Okay, so what you might want to do, cover up part of it and say, okay, well, how would I solve this? I'd want my x alone, so I'd need to move my 7, so I would be moving this over here, and I would do that by subtracting 7 from both sides. Well, if I do it to these two, I also need to do it over here. Okay? So I'm subtracting 7 from all three sides. This gives me negative 6 minus 7 is negative 13. Less than or equal to, that canceled out, x, is less than or equal to, that's thunder, I apologize for that. Well, it's not my fault, but it's in the recording. 10 minus 7 is 3. Okay? So my variable is literally between negative 13 and 3. One thing I want to point out before I talk about how to do the graph or how to do the interval notation is that notice these two signs point the same direction. They always will point the same direction if you have a three-sided problem. The other thing to note is they don't both have to be equal to. I could have a less than and a less than or equal to. I can have a mixture of those. I just can't, they have to point the same direction. And what you end up with needs to be true if you cover up the middle, your variable, and one of your signs. So right here I have negative 13 is less than or equal to 3. That's true. I cover up the other one, and it's still true. Okay, it's because they're both signs, the same sign. All right, so my variable is literally between negative 13 and 3. These are easier to graph than any of the others. You want to put these two numbers on there. Negative 13 and 3. Your variable is literally between them. You shade literally between them. By the negative 13, we have an equal to, so it gets a bracket. By the 3, we have an equal to, so it also gets a bracket. What this tells me is that any number I plug in between negative 13 and 3, if I add 7 to it, it's going to give me an answer between negative 6 and positive 10 every time. There's no infinities involved. It's what we call a bounded. You don't have to know that, but it is bounded. Now to go for interval notation, it's always your left-hand bound, comma, your right-hand bound. So negative 13, comma, 3. These are both brackets. This is also both brackets. Okay, so let's do another one of these three-sided problems. I have negative 15 is less than 3 times p plus 2 is less than or equal to negative 12. Again, these signs point the same direction, but I do have a mixture of them. When you notice that, be really careful. We have a tendency to make them match while we are working the problem. We stop thinking about it and we mess it up. So be really careful about that. That's something you should try to get in the habit of double checking. Let's try. I want to get my variable alone in the middle. Cover up one of them. Ask yourself what you would do. You would distribute the 3 here. We distribute the 3. That doesn't change. So I have negative 15 is less than 3 times p, 3p, plus 3 times 2 is 6, and that is less than or equal to negative 12. Okay, cover one of them up. What would you do? You would move the 6 away from the 3p. Okay, so if I need to do this over here, to get rid of the plus 6, I would subtract 6. But if I do it on one of these two sides, I also have to do it over here. So subtract 6 from all 3 sides. This gives me negative 21 is less than 3p is less than or equal to negative 18. Okay. Now we want our p alone, not 3p. We need to divide by a 3. 3 is a positive number, so I do not have to flip my signs. I need to divide this by 3, so I divide this by 3, and also this. If I needed to divide by a negative, I would need to flip both of these. Okay? This gives me negative 7 is less than p is less than or equal to negative 6. So on my graph, I need a negative 7, I need a negative 6. My variable is literally between them, so I shade between them. This does not have an equal to, so it gets parentheses. This one has an equal to, so it gets a bracket. Now before you stop and think and say, well, that's no solution because there aren't numbers in there. There are infinitely many solutions in here. Negative 6.1, negative 6.25, negative 6.9999999. All of those decimals and fractions are in here somewhere. And all of them, if I pick any number in here and plug it in and do the arithmetic, it will give me an answer between negative 15 and negative 12. Use your graph to pull off interval notation. Negative 7 is your left-hand boundary. Negative 6 is your right-hand boundary, and you use the same symbols you used here. Okay, one more problem. When would you use inequalities in real life? I know you've done this type of problem a million times. Imagine that your test grades are 87, 55, and 68. You have one more test to take, and you want to have an average of at least a 70. Okay, that at least is what makes this an inequality problem instead of an equals problem. Okay, because you're going to be perfectly happy if your average ends up to be a 90, right? Okay. All right, so let's think about how we take a test, how we do take averages. We add them all up and we divide by the number we have. So I have 87 plus 55 plus 68. That's my first 3 tests. And I don't know what my 4th test is, so I'm going to say plus x. Now I need to divide by the number of tests I have. 1, 2, 3, 4. Divide by 4. This is going to be my average, and I want it to be greater than or equal to 70. Okay, so let's add up in the top. Let's simplify that. 87 plus 55 plus 68 is 210. So I have 210 plus my 4th test, which I don't know what it is, over 4 is greater than or equal to 70. Okay, so we haven't worked a problem with a fraction in it with an inequality, but it works the same way as with an equal sign. With a fraction, we tend to want to multiply by the common denominator. I only have one denominator. It's a 4. 4 is a positive number, so I can multiply both sides by 4 without worrying about anything. 4 over 1 times 4 in the denominator, those cancel out. I have, on my left-hand side, I have 210 plus x is greater than or equal to 70 times 4 will be 280. Now get that x alone by subtracting 210 from both sides. And you get that x is greater than or equal to 70. So what do you need on that fourth test? At least a 70 in order to end up with a 70 average.